In Lesson 23, we'll be working with equivalent equations and the additive property of equality, and we'll be learning some really important algebraic concepts in this lesson. And so there'll be some real important fundamental problem-solving skills to know. So make sure and pay attention really well. Rewind the CD as you need to go back over if you don't understand something. Make sure you know this lesson well. So before we start with the additive property of equality, it's good to understand what equivalent equations are. And let's say I had x plus 2 is equal to 5. That's a conditional equation because its truth or falsity is conditioned by whatever value I place in there for x. And there's only one that would make it a true equation, and that would be if x was 3. Now, of course, there are other equations that would be equivalent to that one in the fact that x would have to equal 3 in order for that to be a true equation, like this one, x plus 9 is equal to 12. If x is equal to 3, then that makes that a true equation. So those would be considered equivalent equations because the same value for x makes both of them true. Now, the concept of equivalent equations, that's applied to the additive property of equality. And if you just look at those two equivalent equations that I have drawn there, they look different. If you just look at them, their numbers are different. The only thing they have in common are plus signs, equal signs, and have an x, but the numbers are totally different. And so what the additive property of equality is about is equivalent equations that maybe look totally different, but you still get the same answer. There's only one value that would make both equations true. And for example, in the additive property of equality, let's just use some variables a, b, and c. And let's consider that those are real numbers, so they can be positive, negative, or 0. If a happened to equal b, you could add c to both sides, and you would still have the same equation. For example, if a and b both equaled 2, and c equaled 3, you could add 3 to both sides, and you'd still have the same equation. It would still be a true equation. 5 is equal to 5. Now, this concept, it may not seem like it's that big a deal, but it's super important when you're trying to solve a conditional equation and figure out what its solution or its roots are, or in other words, find out what value satisfies that equation. Let's just do some practice problems and you'll see what I mean by applying the additive property of equality for finding a solution. Look at practice problem A. We have a conditional equation there, x plus 11 equals 24. There's only one value for x that would make that statement true. And so what you can do on these is you can get, in order to get x by itself and to solve for x, you could add a negative 11 to both sides. And so what that does is you have plus 11 minus 11 on the left-hand side, and so those would cancel to 0, and you're just left with x over there now. And then you have 24 plus 11, or just do 24 minus 11, and that's equal to 13. So x is equal to 13. That's the solution or root for that conditional equation. Now, of course, you probably could have just looked at that problem and seen that 13 plus 11 equals 24. You didn't have to add a negative 11 to both sides. And we'll do a few more problems that are pretty easy to do, but I want you to do them using this additive property of equality, because eventually they're going to get too complicated for you to just look at them and be able to do them in your head. Let's go ahead and do some more. Practice problem B. B minus 35 equals 42. So what is B equal to? Well, in order to get B by itself, or just to solve for B, the best way to do that is just to use the additive property and add the same number to both sides. And you want to add a number that will cancel the one next to the variable. So you want to cancel that negative 35 out, and so you add a positive 35 to both sides. And so that cancels on the left, and you're just left with B on the left side. And so then you add 42 and 35, that would be 76. 7. So B is equal to 77. Notice how I'm working these problems. I write them out vertically. I mean, we could add the 35 to the right on both algebraic expressions, the one on the left side of the equal sign and the one on the right side, but I think it just works a little bit better to write them out vertically. So in other words, some people might do it like this: B minus 35 equals 42, and then have plus 35 here and plus 35 here. And so you see that that cancels, and then you add your 42 and 35. So if you want to do them horizontally, you can. I just like to do them vertically like that. Look at practice problem C. C minus 1/4 equals 7/8. So what we're trying to do is solve for C, find out what the root is for that equation. What value of C makes that equation a true equation? And you just need to think to yourself, well, I need to get that C by itself. I need to get that variable C by itself, and then I'll have just it on the left side and then equal to a certain number. The way I can get it by itself is to add, use the additive property of equality, and I can add a positive 1/4 to both sides here. And so on the left, that will cancel, and then I'll have C is equal to, now when I'm working with fractions, a lot of times it's better to write them out horizontally because I need to add numerators and everything, and that just keeps it organized better. Now 1/4, we need to make that 2/8 so that we'll have common denominators, and that will give us 9/8. We don't want to leave the answer as an improper fraction though, so we'll just say 1 1/8. That's our answer. Let's do one more. D plus 3 1/4 equals 2 5/8. Now, in this problem, we have some mixed numbers, so it's a good idea just to go ahead and change those into improper fractions first. And so we'll have D plus 13 over 4 is equal to 21 over 8. Okay, now we want to get D by itself. We want to solve for D and find out what the root is, or solution to this equation. And so we can do that by adding a negative 13 over 4 to both sides. So that cancels the 13 over 4 on the left, and then we'll have D is equal to 21 over 8 minus 13 over 4. We need to have a common denominator here, so that'll be minus 26 over 8. And then finally we'll add algebraically 21 over 8 plus a negative 26 over 8 will give us a negative 5 over 8. And so there's our answer, negative 5/8. If we added that to 3 1/4, that would give us 2 5/8. So in the additive property of equality, as you can see here, it doesn't change our equation. We can add the same number to both sides of the equal sign. It does not change the equation. It doesn't change its solution. It just changes the way the equation looks. And the benefit to using this additive property is to help us find out what the solution is to the equation. We use it to isolate the variable on one side of the equal sign, and then we can figure out what that variable is equal to. Okay, well that's all for lesson 23.